So this lesson is for the Pythagorean theorem, and this theorem is, what you've been researching the past couple of days through your activities, and it's used to find the missing side of any right triangle, not any other type of triangle. The longest side of a triangle is called the hypotenuse, and the hypotenuse is opposite the right angle. The other two sides of the triangle are what we call the legs, and the legs can be found by locating the 90-degree box. The box holds on to the two legs of the right triangle. So although legs A and B can be switched, the easy way to remember that the legs is A for altitude of a figure, altitude also means height, and B for base of a figure. But A and B can really be whichever one you want. So we're going to label the hypotenuse, which is across from the right angle, and the two legs. So here's my altitude and my base. Notice there's my right angle. They're holding on to those two. Now again, we can technically switch the A and the B. It doesn't matter, but an easy way to remember is altitude and base. The important part here is that you always get the hypotenuse on the long side. So the hypotenuse is the side of a right triangle that's always opposite of the right angle. It's the diagonal of the triangle. So if you think about it, we create triangles from a rectangle, well, right triangles anyhow, from a rectangle, and so this is the diagonal of the rectangle. That's the hypotenuse of the triangle. And its measurement is always the longest side. So as you can probably see from here, this is going to be shorter than that, and this is going to be shorter than that. So again, the hypotenuse is the longest side. The legs are the sides that connect to form the right angle. So the Pythagorean theorem that you figured out over the past couple days with your activity is a squared plus b squared equals c squared. So remember, A and B are always the legs, and C is always the hypotenuse. So here was the proof. Again, we had A was 1, 2, 3, 4, so A squared is 16. B was 1, 2, 3, so B squared was 9. 1, 2, 3, 4, 5. 5 squared was 25. And if you plug in 16 plus 9 equal to 25, 25 does equal 25. And again, you've been investigating that the past couple days. So today is just about practicing and making sure we all got it. So let's determine with the following sets whether the triangle is a right triangle. If the Pythagorean theorem works, the measurements make a right triangle. So the first thing you always need to do is identify your hypotenuse. You should know which one that is because it's always the longest side. So we've got a squared plus b squared equals c squared. I'm going to put 12 in for A. It doesn't matter which one goes in for A and B. 16 in for B, and 20 in for C. This is where memorizing your perfect squares really comes in handy because you can spend a lot less time doing calculations. I have all these memorized, so I know that 12 squared is 144, 16, 256, and 20 is 400. So then I really just have to do this addition here. So 6 and 4 make 10. I'm going to carry my 1. 5 and 4 plus my 1 makes another 10. And I'm carrying my 1, so that makes 400. So does 400 equal 400? Yes. So this is a right triangle. On the next one, 15 is my hypotenuse. So I've got a squared plus b squared equals c squared. So it's 5 squared plus 10 squared equals 15 squared. Again, I chose 15 as C because that's my longest side. 5 squared is 25, 10 squared is 100, and 15 squared is 225. 125 is 125. So does 125 equal 225? No. So this is not a right triangle. Okay? So we're going to use what we know about squares and square roots in the Pythagorean theorem to solve the following problems for the length of the missing side. Now these are all right triangles with the hypotenuse missing. So we're going to do a squared plus b squared equals c squared. And we're going to put 6 in an 8n, and I don't know my hypotenuse. So 6 squared is 36, 8 squared is 64, and I don't know h squared. 36 and 64 make 100. Now, because we're dealing with real world, we need to figure out what number times itself, it has to be positive because it's real world, is going to equal 100. The easy way to do this is to actually take the square root. But again, we're only dealing with the principal square root here because we're talking about the real world. So if I take the square root of both sides, I just have h left over. And the square root of 100 is 10. Now, not everybody really has to think about this step like this. However, when you get to algebra, that will be required of you. But what you really just need to be doing is once you get to this point, is saying what number times itself gives me 10. So this side is 10. The next one is going to be a squared plus b squared equals c squared. Again, I have 7 squared plus 10 squared equal to h squared. 7 squared is 49, 10 squared is 100. I don't know h squared. So this is going to give me 149 and h squared. Now the problem here is that h squared, there is not a number times a number that equals 149. So I'm actually going to have to do some estimating here. And that's where that square root property comes in. You have to realize that h is going to be the square root of 149. Now, eventually you will learn how to simplify this, but that's not this year. Right now, what you're going to see on STAR is a couple different things. You might see it written like that. You also may see it estimated to the real nearest whole number. So this is really close to 144. The square root of 144 is 12. So it's approximately 12. And then sometimes it'll actually have some decimal answers. And basically you'll just have to approximate to the nearest whole number and see which decimal makes more sense. So Mr. Thompson created a mosaic tile in the shape of a square to place in his kitchen, which is closest to the length of the diagonal of the tile. Well, we've got 9 and 9. We need to find the diagonal, which is the hypotenuse. So a squared plus b squared equals c squared. That's going to be 9 squared plus 9 squared equals h squared. So this is 81 plus 81. 81 and 81 is 162. That is not a perfect square. So again, we're looking that h is the square root of 162, which if you look at our answer choices, we need to figure out which one that's closest to. So 162, that's going to be really close to 144, which is 12, and 169, which is 13. I would say that 162 is much, much closer to 169. So I'm going to be looking for 13 as my answer choice, which happens to be B here. Okay, before we move on to the next step, I do want to talk about something called Pythagorean triples. And these are useful because they're the ones that are most commonly seen within a triangle. So if you memorize some of these, like we've told you to memorize some other things, then that's going to make your life a little bit easier because you won't have to do those calculations all the time. The most common one that you'll see is 3, 4, 5. But you'll also see some variations of that. If we multiply all this by a scale factor of 2, we're going to get 6, 8, and 10. Which if you notice, that was this one. So we could have skipped all of these calculations by just knowing that that was a Pythagorean triple. What if we multiply by a scale factor of 3 instead? That would give us 9, 12, and 15. This works for any scale factor. This is your Pythagorean triple, and if you recognize those scale factors, you can make your life a little bit simpler by not having to do those calculations. You're always allowed to, you just don't have to sometimes. So another one that you'll often see is 5, 12, and 13. This is also a common Pythagorean triple. And again, any scale factor of that, you're allowed, if you notice it, to just go straight to your answer. Okay? So again, those are all called Pythagorean triples. This is definitely one I recommend knowing and being able to recognize those different scale factors. This one's useful as well, but it doesn't show up quite as often. So now we're moving on to finding a leg. This one gives us the hypotenuse, but we don't have the leg. We're still going to go to our Pythagorean theorem. And I'm going to plug 9 in for A, and I don't know the other leg, so I'm going to put an X. But I do know my hypotenuse. I'm still going to go through and simplify. This is 81 plus x squared equals 225. Except now I have an equation to solve. I want this guy all by itself. So to get rid of a positive 81, I have to subtract 81. This goes away, and you've got that x squared by itself now. So 225 minus 81 gives me 4, and that's going to be 4 and 1. Oh, okay, well that is 12. So your answer is 12. Now, maybe you also noticed that this was a Pythagorean triple. If you divide by 3, that was 3. Divide by 3, that was 4. Divide by 3, that was 5. That's a variation of a 3, 4, 5 triangle. So again, we could have avoided all this work by recognizing our Pythagorean triple. However, it's not always going to work, so you do need to know this method. On our next problem, it's a little more complicated because we've got this square here. And I know it's a square because of those tick marks. So that means this is 8. Now when I look at this, I automatically see, here's my right triangle. I'm missing a side, and I've got an 8 and 10. I already know x is 6 because I know my Pythagorean triples. And I know 6, 8, 10 is a variation of a 3, 4, 5. However, if you didn't know that, a squared plus b squared equals c squared. A, I'm going to use as 8. I'm going to use b for x. And 10 is my hypotenuse, so that's c. 8 squared is 64. 10 squared is 100. Again, I need this guy by itself. So I need to get rid of positive 64 by subtracting 64. This is gone. My x squared is now by itself. And 100 minus 64 is 36. So what number times itself gives me 36? That would be positive 6. My answer is x equals 6 inches. How far up a wall will an 11-meter ladder reach if the foot of the ladder must be 4 meters from the base of the wall? So here's my wall. My ladder is reaching up the wall, and it's an 11-meter. And the base of that ladder, I want 4 meters from the wall. So here's my picture. I'm going to do a squared plus b squared equals c squared. 4 squared, I don't know the other leg, and my hypotenuse is 11 squared. So it's 16 plus x squared equals 121. Again, I want my x squared by itself. So I'm going to subtract 16 from both sides. This goes away and leaves behind my x squared. This becomes an 11 and a 1. So I can do 11 minus 6, which is 5, 1 minus 1, which is 0, 1 minus 0, which is 1. Now, I don't know what the square root of 105 is, but I do know that it's really close to 100, and on the other side is 121. So I'm going to say my number is going to be pretty close to 10 meters. Or you could also just leave your answer as the square root of 105 meters. The diagram shows the dimensions of a water slide. So here's your water slide. Donovan goes down the slide at a rate of 5 feet per second. How long will it take him to reach the bottom of the slide? Okay, so we're looking for how long it's going to take him, but before we can figure that out, we need to know how long that is, which involves a right triangle. When you look at this again, you can do a squared plus b squared plus equals c squared, but hopefully you've started to kind of notice already, if I divided that by 10, it would be 3. I can also divide that by 10 and get 4. Oh my goodness, this is a 3, 4, 5 triangle, except it's a variation of it. So it's not 3, 4, 5, it's actually 30, 40, 50, because you'd have to multiply this by 10 to get back there. So you can do the Pythagorean theorem if you need, but use the triple if it's there. So since that is 50 feet long, it says it's doing 5 feet per second. So I'm going to divide by 5 to figure out that it's going to take me 10 seconds to get to the bottom. Sorry. All right, so that's my last example, but I do actually want to add one more thing to these notes. There will be times where you're going to have a coordinate plane. So let me just actually add some here so that we make sure we're a little more accurate. There are going to be some times where you're going to see a coordinate plane and you're going to be asked to find the distance of a line segment. Distance meaning how long is it? So I'm going to say this is my 0, 0. So this is 1, 2, 3, 4, 5, etc. This is 1, 2, 3, 4, 5, 6, etc. So what if I had a segment from here to say here? And it asked you how long that was. Eventually you're going to learn something in algebra called the distance formula. But that is actually developed from the Pythagorean theorem. And the distance formula is a little bit complicated. So if you get asked this before then, or even then, you could find another way to do it. My suggested way is, I know that's a right angle because it's a horizontal line and a vertical line intersecting. So if I do this, this is 3 units long. And this is 3 units long. I now have a right triangle. So I can do a squared plus b squared equals c squared using 3 and find my h. This is going to be 9 plus 9, which gives me 18. So h is going to be the square root of 18. Or you may actually be asked to approximate that, and so that would be really close to the square root of 16, which is 4. And the other side would be 25, so it's definitely closer to 4. So that would be approximately 4 units. Okay, so that's all we got for today. Please complete the assignment in the next few pages of your packet.